Hello, my amazing students. This is Mrs. A, and I love math. And today we are back with lesson 29 in your Saxon Orange Book. And we are doing negative exponents and zero exponents today. So we are going to give an example of the rule, and then we're going to give the rule down here. So 1 over 5 to the second power is the same thing as 5 to the negative second power. So when we take something and we want to change the sign of the exponent, we flip it across the division sign. So here we have 1 over 5 to the negative 2. But when we flip it up over the division sign, it becomes a 5 to the 2, a positive 2. So here is our definition. Definition of x to the negative n. If n is any real number and x is any real number except x can never be 0, then 1 over x to the n is equal to x to the negative n. So 1 over x to the positive n is equal to x to the negative n. And we're going to show lots of examples of this shortly here. Okay, so here we have some examples. We're talking about negative exponents and the fact that when we turn them around, make a reciprocal, all we have to do is change the sign of the exponent. 1 over 3/4, when we want to flip it over and make a reciprocal, because wouldn't this be 3 to the negative 4 over 1? So the reciprocal we can write with just changing it to a negative 4 instead of a positive 4. Here I started with a negative 3, so when I flip it down it becomes a 3. 6 to the negative 3 is 1 over 6 to the third. 7 to the negative 2 is 1 over 7 squared. 1 over 5 to the negative 8 is 5 to the 8th. Okay, so our rule is this. A number of or variable that is written as an exponent can be written in reciprocal form if the sign of the exponent is changed. It's as easy as that. Okay, so if our exponent starts with positive, then the reciprocal will have a negative exponent. When our exponent starts with a negative, its reciprocal will have a positive exponent. So let's evaluate these. So 3 to the negative 2 is too hard to think about. But if we change it to 1 over 3 squared with a positive exponent, then we know that 3 squared is 9. So this becomes 1 over 9. And now it's easy to think about, okay? This one is 1 over 3 to the negative 3. Okay, so if our exponent starts with positive, then the reciprocal will have a negative exponent. When our exponent starts with a negative, its reciprocal will have a positive exponent. So let's evaluate these. So 3 to the negative 2 is too hard to think about. But if we change it to 1 over 3 squared with a positive exponent, then we know that 3 squared is 9. So this becomes 1 over 9. And now it's easy to think about. For the next one, we start with 1 over 3 to the negative 3. But we want a positive exponent. So we're going to move it up, and it's going to become 3 to the third upstairs. And 3 to the third is 3 times 3 times 3, which is 27. Okay, here, we got a lot of work to do. We've got negative 3 to the negative second power. So we're going to put it, and I'm going to leave my negative 3 in the parenthesis, but now it's going to become the second power. Because it started negative, I changed the exponent to a positive when I get the reciprocal. So now, again, it's easy to think about. 1 over negative 3 times negative 3 is positive 9. And again, we have 1/9. So now we're talking about the product rule for exponents. If m and n are real numbers and x does not equal 0, then x to the m times x to the n equals x to the m plus n. In other words, when we multiply like bases, remember these are the bases, then we add the exponents together. Cool rule. So now let's look at 3 examples. So if you have x to the negative 5 times x to the 2, remember we don't have to put the little dot here. We can just put them close to each other, and that means multiplication. Then since they're the same base, we add the exponents. Negative 5 plus 2 is negative 3, and we get x to the negative 3 as the answer. Okay, on the next one, we have 3 bases, y to the 7, y to the 5, y to the negative 2. Since they're all the same, we're going to add the exponents together. 7 plus 5 minus 2 is 12, minus 2 is 10. So the answer is y to the 10. And this is a third example. P to the 10 times p to the negative 15 is p raised to the 10 minus 15, which is p to the negative 5, or 1 over p to the 5th. And we'll be back with some more. Okay, so we have 2 examples. We're to simplify these 2 expressions. All right, so we have to look for the like bases. So we have an x and an x. Those 2 we can multiply together. So we're going to have an x to the 4 minus 2 and an m raised to the, since we have an m and an m, 2 minus 5. X to the 2, m to the negative 3. Now, let's take it one step further. What if I didn't want a negative exponent? What if I wanted only positive exponents? Then I would have to slip this one downstairs, and it would become x squared over m to the 3. This is considered to be the most simplified form because we usually don't like to leave that negative exponent. So we drop it down to the denominator and make it x squared over m cubed. All right, let's look at this one. Oh my goodness, I have x's and y's and z's. So my x's can go together, and I'll have x and x and x. Now remember, since this one doesn't have an exponent, it's a 1. So I have x to the negative 2 plus 4 plus 1. And then I've got a y, and I've got a y here and a y here, and no more y's. So y to the negative 6 plus 5. Okay, so I've taken care of my x's. I've taken care of my y's. And now I look at my z's. And again, this is a z to the 1. So I get z to the 1 times z to the 5. And that's going to be z to the 1 plus 5. So my final answer is going to be x, negative 2 plus 4 plus 1 is 2 plus 1 is 3. So I get x to the 3, y to the negative 1, and z to the 6. Now, can you tell me what would be the simplest form of this answer? Wouldn't I have to drop the y downstairs? And since it would become a y to the 1, we don't have to write y to the 1. We can just put y. So my final answer for this one would be x cubed z to the 6 divided by y. Okay, so here, now we're talking about 0 exponents. Any number divided by itself is 1. We know that. So 5 divided by 5 is 1. Or 4 squared divided by 4 squared must be 1. So now let's take this apart using our product rule. So 4 squared divided by 4 squared is 4 squared times the reciprocal, which is 1 over 4 squared. And then 4 squared is 4 squared, but 1 over 4 squared, by the rule we learned of negative exponents, is 4 to the negative 2. So when I multiply those two together, don't I get 2 minus 2, which is 0? So 4 to the 0 is 1. So now we're going to learn that anything to the 0 power is 1, as long as the real number that we're raising to 0 is not 0. Okay, so if x is any real number that is not 0, then x to the 0 is 1. Now, this is a rule. It's the 0 exponent rule. Okay, so now look at this one. Look at this huge quantity that I raised to 0. Okay, so I have x plus y plus z squared. As long as this is not 0, then whatever it is to the 0 power is 1. P times m is raised to the 0 power. And as long as p times m is not 0, then the answer is 1. You could really get your friends on this one, right? So px to the negative 4, when the whole thing is raised to 0, is 1. 5 to the 0 is 1. Isn't that a cool rule? Okay, so here we have x squared, y to the 5th, y to the negative 2, x to the negative 2, all multiplied together. So we're going to join the x squared and the x to the negative 2 to get x to the 2 plus a negative 2, or 2 minus 2. And then y to the 5th and y to the negative 2 would be y to the 5 minus 2. So now I simplify those. 2 minus 2 is 0, so I get x to the 0. Y to the 3rd, and then the x to the 0 is 1. So I can just cancel it out. I don't need to put 1 y cubed. It's just y cubed. That is the answer. Okay, so let's look at this one. We are to distribute this through this whole parenthesis. Since these are not alike, I cannot do anything to them separately, but I can distribute. So I'm going to multiply all this out. X to the 5, y to the 0, z, p to the negative 3, z to the 0. Okay, so that's going to be the first one, minus 4, x to the 5, y to the 0, z to the 1, and then over here, I've already got the negative 4, x to the negative 5, z to the negative 1. I'm about to run off my board. That's a long problem. Okay, so now I have to simplify all of this. So let's get a little bit more board space. So now I erased all of this. So x to the 5 has no other x to multiply by. So we're going to leave it x to the 5. Y to the 0 has no other y. So y to the 0 is 1 though, so we don't have to write it down at all. So we took care of those two. Z to the 1 times z to the 0 is z to the 1 plus 0, which is just z to the 1. And because it's a 1, I don't need to write it up there. And then p to the negative 3. There's no other p term there. So we took care of all of that, minus, now we're going to do this one. 4. We have an x and an x. So we have x to the 5, x to the negative 5. Well, x to the 5 minus 5 is x to the 0. X to the 0 is 1. So we can cancel those out. Y to the 0 is 1. So we can cancel that one out. Z to the 1, Z to the negative 1 is Z to the 1 minus 1, which is Z to the 0. Z to the 0 is 1. So we end up with this, because everything else was 1, that is our answer. Okay, so now we have x to the 5, z, p to the negative 3 minus 4. So that whole gobbledygook simplified to that. I missed a little example, so I'm going backwards. M to the 5, and then over here we have another m, which is to the 1. So m to the 5 times m to the 1 is m to the 5 plus 1. And then we have 2b, so b to the 2 minus 2. So we're going to get m to the 6, b to the 0 is 1. So our answer is m to the 6th. Okay, a couple more problems and we'll start our practice problems. So here, because we cannot add these two together, they are not like terms, we must distribute to simplify. So we're going to take this one and multiply it by this one. So we would have x negative 2, y negative 2, x squared, y squared, plus this one times this one. So x negative 2, y negative 2, and then we have a 4, so we'll put the 4 on the front, x to the 4, y to the 2. Okay, now because I have, this needs more work, doesn't it? So I've got an x, so let's look at this term right here. And in this term right here, I have an x to the negative 2 times an x to the 2. So I get an x to the 2 minus 2, which is an x to the 0. So x to the 0 is 1, isn't it? All right, so then I have y to the negative 2 times y to the 2. Well, aren't they going to turn into 1, right? Negative 2 plus 2 is 0, so y to the 0 is 1. Now, I'm not going to cross that out without writing down the 1, because it was really 1 times 1, right? Because this turned into 1, and now this turned into 1, and they're all multiplied together, so it's 1 times 1 is 1. I can't lose the 1. Okay, so then plus, and then what happens to all of this? So we have a 4, and then we have a y to the negative 2 and a y to the positive 2. So y to the 2 minus 2 is y to the 0. That can just cancel out. X to the negative 2, x to the 4. 4 minus 2 is 2, so it's x to the 2. So the whole thing became 1 plus 4x squared. All right, so now let's look at this. They're trying to get us to see something very important here. 2 to the 0 is 1. The exponent always applies to the number or the variable right before it. That means because there's no parenthesis here, the 0 does not apply to the negative. So this is the same thing as the opposite of 2 to the 0. Well, 2 to the 0 is 1. So the opposite of 1 is negative 1. Very important. Now we have negative 2 included in the parenthesis. It's all raised to the 0. Remember, any number that's not 0, that's raised to the 0 power, is 1. So this one was 1, this one was 1, but this one was the opposite of 1, or negative 1. Okay, so these are the first 6 of your practice problems. So I want you to copy them all down and then pause your video and go do them yourself and practice. Okay, so 1 over 2 to the negative 3. Remember, we don't want the negative 3. We really don't know how to interpret it very well. So we're going to turn it into a positive 3 by sending it up. So this is the same thing as 2 to the positive 3. And 2 cubed is 8, because 2 times 2 times 2 is 8. So the answer to this one is 8. -4 to the -2. Again, that -2 gives us problems, so we're going to get the reciprocal. So this is going to be 1 over -4 to the second power. That's easy to evaluate because -4 times -4 is positive 16, and the answer is 1 over 16. Okay, so now notice no parenthesis. The 0 only applies to the 8. 8 to the 0 is 1, but this is the opposite of 8 to the 0. So its answer is -1. Let's look at this one. Again, negative exponent, too hard to do. We're going to bring it upstairs with a positive exponent. And now we're getting 3 squared is 9. 8 to the 0 is 1. -3, all in a parenthesis to the 0, is 1. See how fast we did? 6 problems. Okay, so here's your board. Get those down. And we only have a few more practices, and then you'll be off to do your homework. Okay, so we just have a few more. And this one is one of them. So we have p plus m plus k squared inside a parenthesis, and on the outside of the parenthesis is a little 0. So what is the answer? Anything raised to the 0 power, as long as this is not 0. It can't be 0. Anything else raised to the 0 power is 1. So the answer is 1. And then we have, oh my goodness, such a long one. So we've got x's, and let's put them together first. So x to the -3 times x to the 4 times x squared. X to the -3 times x to the 4 is x to the 1 times x squared is x cubed. So now we took care of all the x's. So now we're going to take care of all the y's. So we have y, y, and that's all the y's. So y to the -8 times y to the 5. -8 plus 5 is -3, so y to the -3. And those go out. And then we have a z, which is a z to the 1, times a z to the 5, which is a z to the 6. And that goes out. Now, the only thing that we can do to make this better is to take this one and get its reciprocal instead. So we're going to say, use the reciprocal form. So we're going to say that is equal to x cubed z to the 6th over y to the 3rd. And remember, when I flip it downstairs, I change the sign. And there you have it in its most simplified form. And those 2 problems. Okay, so here we have another one. And we have x's, and then we have y's. So x to the 6 times x to the 2 is x to the 8, because I add them together. Y to the -3, y to the 3, I add together the -3 and the 3, and I get 0. And y to the 0 is 1. So x to the 8th times 1 is just still x to the 8th. I think we have one lot more problem. Last problem. So again, we cannot do what's inside the parentheses, so we must distribute. We're going to take this and multiply it here and here. So we have 2x -2y cubed. All of this is times x squared y minus, we just bring the sign down, 2 times a -3 is a -6. I'm going to go ahead and multiply those. But then you can either multiply or just write it all down. So I'm going to do the second one by just multiplying as I go. So I have an x to the -2 and an x to the -1 that I'm multiplying together. So I add their exponents, and I'm going to get an x to the -3 a y to the third times a y to the negative 3. 3 minus 3 is 0, so I'm going to get just a 1, which we can just get rid of because we don't need it. So I simplified this one as I went, except I don't need this, right? So I don't need that there. But this one, I just wrote these and wrote those, and now I'm going to simplify it. So you can do it either way. Either way is correct. So here is going to be a 2. We have an x to the negative 2 and an x to the 2, so aren't those going to become 1? And this is a y to the 1, so a y to the third times a y to the 1 is a y to the fourth minus 6x to the negative 3. And if I wanted to, I could write that x to the negative 3 downstairs. So what if I just did this? What if I just said minus 6 over x to the third? So 2y to the fourth minus 6 over x to the third. And we're done with lesson 29. Man, that was a long lesson. And this is Mrs. A, and may God bless your day.